I'm Eileen G. Espanueva from BSECE1GH. Now, we will solve optimization problems. Let's take a look. Sabi sa problem, the can must have a volume of 1,000 cubic inch and we are asked to find the dimensions that will minimize the amount of metal needed in this construction of the can. I want to draw first the cylindrical can to have visualization. Let h is equal to height. R is equal to radius, and we have a given of B is equal to 1,000 cubic inch, and we know that the formula for volume is B is equal to phi r squared times h. Since we are asked to minimize the metal needed, we can do that by minimizing the surface area, where area formula is 2 pi r, which is the circumference of the circle times height of the can, so that gives you the outside structure of the can. Then phi r squared is the area of a circle, and we times it to 2 because of the top and bottom, and combining it together we will have this surface area equation. A is equal to 2 phi r times h plus 2 pi r squared. Now, we want to reduce this equation to just one variable. And I think let's go solve for h in terms of r because it's easier to plug it in the area equation. V is equal to pi r squared times h. Since we have given a volume of 1,000 cubic inch, we can plug it in. 1,000 is equal to phi r squared times h. Because we want to solve for h, we divide both sides by pi r squared, then cancel out. Then we can have h is equal to 1,000 over phi r squared. Now, we can use it in area equation. A is equal to 2 pi r times 1,000 over pi r squared plus 2 pi r squared. This is now in the form of one variable, which is r. Let's simplify. Pi and r squared are cancelled out. And it will give us a is equal to 2,000 over r plus 2 pi r squared. Now, let's take the derivatives. Para mas madali ang pagkuha ng derivatives, ginawa na lang natin na a is equal to 2,000 r raised to negative 1 plus 2 pi r squared. Applying the power rule, it will give us a prime is equal to negative 2,000 r raised to negative 2 plus 2 pi r. And ibalik lang natin yung kanina in the form of fraction, whereas negative 2,000 over r squared plus 2 pi r. Now, let's find the common denominator. The common denominator is r squared. And after that, it will give us a prime is equal to 4 pi r cubed minus 2,000 over r squared. And ngayon, we want where this area derivative equals to 0 because that will give us the lowest point. Now, let's set it to 0 and solve for r. Let's times it to r squared, and r squared are cancel out. That will give us 4 pi r cubed is equal to 2,000. For solve for r, we just cancel out hanggang r lang yung matira. Then taking the cube root, it will turn into r is equal to cube root of 500 over pi. Let's plug it into the height equation to solve for height. So h is equal to 1,000 over pi times cube root of 500 over pi squared. To get rid of the cube root, it will turn into h is equal to 1,000 over pi times 500 over pi raised to 2/3. And using the calculator, it will give us h, or the height, is equal to 10.84 inch. And for the radius is equal to 5.42 inch. Therefore, the dimensions that will minimize the amount of metal needed in the construction of the can is h is equal to 10.84 inch and the radius of 5.42 inch.